Hi everyone, I'm Priya, Technical Marketing Engineer from the Aruba Switching Business Unit. In today's session, I'll take you through AOS-CX 10.15 release update, OSPFv3 address families. So let's jump into the feature. So here's the usual agenda for our session. So we'll look at the overview of the feature, few important use cases, followed by details and caveats and how to configure this on the CX boxes. We will also take a look at few best practices, troubleshooting methods, and finally followed by a demo. So let's look into the overview of the feature. So OSPFv3 address families, that is AF, allows OSPFv3 to handle both IPv4 and IPv6 routing. To distinguish between these two, each address family IPv4 or IPv6 is assigned to a unique instance ID range. These instance IDs help identify whether a specific OSPFv3 process is handling IPv4 or IPv6 routing. However, the core structure of OSPFv3 remains relatively consistent. The presence of a separate link state database per address family is also easier to debug and operate. Additionally, it doesn't change the existing instance area. and interface-based configuration model in most OSPFv3 implementations. This feature is new to 10.15 and it enables both IPv4 and IPv6 unicast traffic to be supported. Also, by design, we allow one OSPFv3 address family instance for IPv4 and one OSPFv3 address family instance for IPv6 to be configured per interface. An important thing to note here is that if IPv4 address family is used, IPv6 link local must be enabled on the interface for this to work. This is because OSPFv3 operates on these as base, that is the link local addresses. This will also work with autoconfig CLI. So you can refer the RFC 6969 to know more about the OSPFv3 instance IDs and RFC 5838 to read more about the address family support in OSPFv3. So let's look at why OSPFv3 address families are important. So the first is flexible routing information sharing with LSAs. So LSAs in OSPFv3 are enhanced to support both IPv4 and IPv6. No new LSA types are needed, which provides a smooth transition and interoperability with existing OSPFv3 functionality. The next one is independent route calculation for each address family. Each AF has its own routing table. For example, OSPFv3 will calculate IPv4 routes separately from IPv6 routes, thus ensuring accurate and independent routing paths for both these protocols. Following that is the dedicated database for IPv4 and IPv6 AFs. OSPFv3 maintains separate database for each AF, which ensures changes in one AF does not affect the routing calculations or stability of other, thus improving the network reliability. And finally is the link local address. Each router uses IPv6 link local addresses for OSPFv3 communication while supporting either IPv4 or IPv6 routes. So for this, we'll have to enable the IPv6 address link local CLI, or we can also go ahead and enable the IPv6 address autoconfig CLI. This should work with both. So let's talk about instance ID for IPv6 and IPv4 unicast. Each instance ID implies a separate OSPFv3 instance with its own neighbor adjacencies, link state database, protocol data structures, and SPF computation, that is the shortest path computation. Talking about the instance IDs for IPv6 unicast address family. So the range for this is from 0 to 31, whereas The first value in this range, that is instance ID 0, is the default value for IPv6 unicast. Followed by this is IPv4 unicast AF. So the range for IPv4 unicast AF is from 64 to 95, and the first value in this range is instance ID 64 is the default value for IPv4 unicast. So OSPFv3 address families can be configured on physical ports, VLAN, lag, and loopback interfaces. The same instance ID can be reused on different OSPFv3 AF processes, and it follows the same scale as OSPFv3 in case of the VRFs. So one thing to highlight here is the best practice of using the instance IDs, which is to configure the default values for the instance IDs for both IPv4 and IPv6. So let's look at a comparison on OSPF v2, v3 and v3 AF. So to my left are a list of features, and to the right I have a comparison of all the three versions. So though OSPF v2 offers only IPv4 support, v3 offers IPv6, but OSPF v3 address families offers dual stack support, which is a very important thing to note here. And OSPF v3 also includes separate address families for IPv4 and IPv6, which is not the case in v2 and v3. So talking about the route advertisement, v2 advertises only IPv4 routes and v3 IPv6 routes, whereas address families advertise both IPv4 and IPv6 routes simultaneously. So the next is the instance requirements, which is single instance for OSPF v2, that is IPv4. OSPF v3 requires separate instances for IPv4 and IPv6, whereas address families has an advantage of having a single instance that handles both IPv4 and IPv6. The next is the LSA types, which is pretty straightforward as you can see in this table. So is the transport protocol as well. Let's jump directly to the resource usage. So the resource usage is minimal for IPv4 only networks in OSPF v2. And in OSPF v3, it is higher with separate instances for dual stack. Whereas in address family, since we have a single instance, there is minimal resource consumption and is more efficient for dual stack setups. So here are the supported platforms for OSPF v3 address families. You can take a look at this table. So now let's move on to the next part of the session, that is the use cases. So before we deep dive into this address family use cases, we have to understand what's the case without OSPF v3 address families. So I have four major points here. The first one would be a separate OSPF v2 or v3 process would be needed to manage IPv4 and IPv6. The next would be additional complexity, resource usage and operational overhead. Following this is managing and troubleshooting two separate routing instances, which can be troublesome. And finally, it's the unoptimized network monitoring. So these are the problems without OSPF v3 address families. So now let's look at what are the actual use cases for OSPF v3 AFs. So the first is dual stack networks. As OSPF v3 AF supports both IPv4 and IPv6, this ensures efficient operations in dual stack environments. So the next use case is single instance management. A single OSPF v3 instance handles routing for both IPv4 and IPv6, reducing resource usage on network devices. The third use case would be enhanced security. It seamlessly integrates with IPsec for native support of authentication and encryption. And finally is the interoperability. It is ideal for mixed hardware environments in enterprise networks, ensuring flexibility and reliability. So dual stack with OSPF-v3 address families. With OSPF-v3 address families, a single OSPF-v3 instance can support both IPv4 and IPv6. This dual stack routing is a very huge advantage here. The next is optimized traffic flow. This efficiently facilitates routing between IPv4 and IPv6 networks for internal and external communication, thus improving the overall network performance. And we also wouldn't have any service disruption because the dual stack approach ensures continuous operation of networks during transition, thus avoiding any service outage. Having separate address families creates distinct routing tables for both IPv4 and IPv6, thus allowing administrators to tune the routing policies independently for each protocol. And finally is the seamless integration. So OSPF-v3 ensures integrated efficient routing across both address families without requiring additional configuration complexity. So to your left is an example where I have two core routers, core 1A and core 1B. Also the AG1A or AG1B. So in my core or AG1A, I have assigned an IPv4 and IPv6 address. Similarly, in my core 1B, IPv4 and IPv6 address, I have enabled link local on both of them so that address families take effect. So here the new CLI that we are introducing as a part of 10.15 is the OSPFv3 AF and then followed by the process ID with either the IPv4 or IPv6 unicast AF and the area allocated to them. And finally is the instance that is mentioned here. So the instance ID is preferred to be default, but it is up to you to change the instance ID's values. But the best practice is to have them as default values. So which is 64 for IPv4 and 0 for IPv6. So same is the case for my core or AGB2. So finally, in my global context, you can see that there is a single OSPF process, one, which manages both IPv4 unicast and IPv6 unicast. So that is with the dual stack use case. So let's move on to the next use case, that is transitioning to IPv6 while still retaining IPv4 for management or monitoring purposes. So this supports gradual IPv6 adoption across different parts of the network without requiring any immediate or large-scale changes. And it also facilitates mixed environments where some regions or devices are IPv6 ready while others continue to still use IPv4. For example, let's have a full IPv6 underlay with IPv6 loopback handling the traffic routing, whereas the management or NMS tools may require IPv4, while the other traffic can be on IPv6. So in such cases, this is really useful. So to my left, I have two examples here. So here is an IPv4 only network. This is being transitioned to an IPv6 underlay network, whereas the IPv4 would be used for monitoring or NMS tools. This supports phased migration where parts of the network or certain devices move to IPv6 while legacy systems continue operating on IPv4. So this helps in reducing any operational risks and minimizes the impact of immediate changes. So let's talk about the details and caveats for this feature. So we have to understand the OSPF-v3 packet header format. So here in this diagram, in the middle, the first 4 lines indicate the general OSPF-v3 header, whereas the rest is the packet itself. So here, the options field is the very important one, which we'll be talking about in the upcoming slides. So this is the field that plays a crucial role with respect to address families. I've also explained each of the field in the packet that you can go through in this slide. So let's talk about the OSPFv3 address family bit details in options field. So in the options field, we have the V6 bit as well as the AF bit that's telling us it is an OSPFv3 address family router that is talking to its peer. And here's an example of the output captured with the OSPF hello packet details, where I can see the options field is set to AF, thus telling us it is an address family OSPFv3 router. So a few more details that I'd like to highlight are that when a configuration is applied on global router context, this configuration is internally applied to all address families, both IPv4 and IPv6. In case the user applies the configuration in global and AF contexts with different values, then the values configured in the AF context take higher precedence and is applied to the protocol. To use the IPv4 unicast address families in OSPFv3, you must definitely enable the IPv6 link local address, although the link may not be participating in IPv6 unicast AF. A maximum of 8 OSPFv3 address family processes are allowed per VRF. And the switch allows configuration of OSPFv2, OSPFv3, OSPFv3 IPv4 AF, and OSPFv3 IPv6 AF. But at any point, only 8 OSPF process per VRF can run per address family, which is 8 for IPv4. Combining both V2 and V3 IPv4, that is OSPFv2 and OSPFv3 IPv4, and 8 for IPv6, that is combining OSPFv3 and OSPFv3 IPv6 AF. So here is an example where I have tried to assign router OSPFv3-AF process 1 in the default VRF, and I'm trying to assign more processes. So this tells us that maximum of only 8 OSPFv3 address family processes are allowed per VRF. So here is just a snip of that as well. So moving to furthermore caveats. IPv4 IPv6 OSPFv3 address family process running multiple instances on the same interface is not supported. And also, one thing to notice here is that only the most recent instant ID configuration will be applied and taken in effect. So for example here, in my interface 1/1/3, I have OSPFv3 address family with the process ID 110 and IPv4 unicast area 0 with instance ID 64. Now I go ahead and assign the same command with an instance ID 65, but you can see that in the show run only the instance 65 is taken into effect. Similarly is the case for IPv6 as well. There is already an instance ID 0. I go ahead and assign an instance 1 so that finally only 1 is taken into consideration. So here, as a third scenario, I am trying to create another process ID 111. So OSPFv3 AF 111, IPv4 area 0, instance 64. Inside the same interface 1/1/3. So this doesn't let me create because OSPF interface cannot belong to more than one OSPF process at a time. So these are few caveats that we should note about. Another set of caveats that I'd like to talk about are dynamic election of router ID is not supported when multiple OSPF processes are configured on the same VRF. Explicit router ID configuration is required on each OSPF process. OSPFv3 AF routers cannot establish neighborship with OSPFv2 routers as they are not operated on linked local addresses. OSPFv3 AF processes cannot form neighbors with peers that don't support OSPFv3 AF or OSPFv3 instance IDs for that matter. OSPFv3 AF area level IPsec authentication is not supported, but we have support for interface level IPsec. Instance ID mismatch is not supported per interface, which means the user can identify the mismatch in the instance ID by doing a walkthrough of the logs, that is the debug logs, and monitoring these debug logs for the specific interface to identify the logs for mismatched instance IDs where it is not flagged explicitly. IPv4 virtual links are not supported in OSPFv3 AF IPv4. This is because OSPFv3 with IPv4 AF still relies on IPv6 link local addresses for its transport. It does not have globally reachable IPv6 addresses that can be used to span multiple hops for a virtual link, and hence this is not supported. IPv6 link local addresses are only meaningful on a single local link, which means they cannot be used to form neighbor adjacencies over multiple hops or across different OSPF areas. There is no support for SNMP, MIPS or traps in 1015 for OSPFv3 address families. We do not have explicit support for event logs of OSPFv3 AF, whereas it is included in OSPFv3 itself. And finally, multicast address families are not supported. So, a few caveats about the BFD session interoperability. Cisco uses IPv4 address base for IPv4 unicast to form BFD sessions, while OSPFv3 address families are built on link local addresses. If BFD is enabled for OSPFv3 IPv4 unicast family in AOS-CX switches, then BFD session is not formed as link local address is missing in this case in Cisco. And finally, the following configurations are not supported in router context but in address family context for OSPFv3 AF in the CX boxes. So let's take a look at the configuration. So this is a sample configuration on the core switches. I have two 8360s, and here I have done a show run OSPFv3 AF on both these switches, and I can show you the global running configuration. So I have created this OSPFv3 AF 110 in my interface 1/1/15 with an IPv4 and an IPv6 unicast and the respective areas and instance IDs assigned to each other on both the sites. I've also created respective loopbacks, loopback 1 and loopback 2 for these two switches, and also populated the OSPFv3 AF routing commands here as well. So once I do a show run interface on both these switches, you can see the below configs being applied to them. I also have an IPv4 and an IPv6 address with the link local enabled as well. So here is an example of loopback address configuration for both IPv4 and IPv6. And finally, the OSPFv3 AF neighborship establishment on 8361, that is the first switch. So when I do a show IP route, you can see that the routes are learned over OSPF, and I also do a show IPv6 route. Similarly, the IPv6 routes are also learned over OSPF. So this 100.100.100.100 is a static route that I assigned in my first switch. So in case you want to advertise this route as well, you just do a redistribute in the address family context, and you will see that being advertised to your peer. So this is the OSPF neighborship establishment in my switch 2, that is 8362. And here also I do a show IP route and show IPv6 route. You can see the routes are learned over OSPF as well as my static route is learned over OSPF. I redistributed this route in my first switch, and I can see that here, as well as my show IPv6 route output as well, where IPv6 routes are learned over OSPFv3 AF. So to your left, I have VRFs, that is VRF 10, 11 and 12 attached to VLAN 710, VLAN 711 and VLAN 712. I also have my respective IPv4, IPv6 and OSPFv3 address family context commands in place here. And to the right is the global level context, where you can see that router OSPFv3 AF1 process attached to VRF10 has IPv4 and IPv6 unicast families along with the router ID and the areas allocated to them. So is the case for VRF11 and VRF12 as well. So this is just a sample configuration on how OSPFv3 address families are configured in case of multiple VRFs. So moving on, we'll also talk about a sample BFD and IPsec configs over OSPFv3 AF. So first let's talk about BFD here. So OSPFv3 IPv4 and IPv6 BFD config is simple and straightforward. So under my interface context, I just assign this command OSPFv3-AF IPv4 BFD, and for IPv6 it's IPv6 BFD. So same is the case on my second switch as well. Following this is the sample IPsec configuration, which is to be enabled on both the sides for it to take effect. So under my interface config again, I have OSPFv3 AF authentication IPsec and the SPI and SPI index, the auth type, and then if it's a ciphertext or a plain text, that is the key type is either ciphertext or plain text, and the auth key. So let's move on to REST API configuration. So from my switch web UI, I opened my REST API for the switch in 10.15, and under the put system interfaces context, I've selected the particular interface which I want to configure my IPv4 and IPv6 addresses. So in the previous one, I assigned my IPv4 address, and here is my IPv6 address assignment. And following this, I also have the node address RA prefix and RA route commands executed under the static IP address contexts. And next, moving on, we go to the OSPFv3 AF router context configuration for both IPv4 and IPv6. So this is done under System VRFs OSPFv3 AF routers. And you can see the router ID being assigned here 1.1.1.1, and which is also under the default VRF. I'm also mapping the respective instance tag of 1 to the OSPFv3 A4 routers, as well as my OSPFv3 A6 routers. And now I'm getting into System VRFs OSPFv3 AF routers and the router instance tag under the default VRF and the instance tag of 1, and executing this set of commands for both AF4 and AF6. So next is my area definition for IPv4 under the default VRF and router instance tag 1. Similar is the case for IPv6 as well. So I define the area here as well, like I did for IPv4. And finally, we map the instance tag to AFv4 and the area. As well as for AFv6. So this is how your REST API config should look from the switch which is being pushed from the REST APIs. So let's look at few equivalent configurations for AOS-CX, Cisco and Comware with respect to OSPFv3 AF. So the first one is in the AOS-CX boxes, which we already saw in the previous slides in the configuration part. And next is the Cisco configuration for OSPFv3 AF. They do not have the OSPFv3-AF context here, whereas it is being executed in the OSPFv3 context itself. Following this is Comware. Same is the case for Comware 2, and here are the supporting configurations for both these vendors. So let's look at the best practices for the OSPFv3 address families. So all three, that is OSPFv2, v3 and v3 AF, can coexist on different interfaces in a CX switch, and neighborship will come. This is not a restriction, but it is recommended to not have all three together. Configuring OSPFv2, v3 and v3 address family on same interfaces is not supported as of 10.15. OSPFv2 and v3 AF cannot form neighborship due to underlying link local address mismatch. OSPFv3 and v3 AF routers with instance ID 0 can form peering with each other. Well, this would work, we do not recommend this. So let's move on to the troubleshooting part of this feature. So here's the list of both IPv6 and IPv4 show commands for both global and interface contexts. You can take a look at this. I've also referenced few clear commands that can be used in the OSPFv3 address families context. So let's talk about OSPFv3 diagnostics and show tech. So I get into the diag mode of 8360 and I issue the CLI diag OSPFv3 LSDB dump. And this command can help you give the LSDB dump for that particular AOS-CX box. Following that is the show tech OSPFv3 AF. Here's a snipped output of this, and this command will give you the timestamp of when it was executed and for which feature it's being executed, and it will also give the address families IPv4 unicast and IPv6 unicast details. And this output, that is the show tech OSPFv3 AF output, can be stored in a local file, and here is the CLI for it. So let's take a look at debug logs for this feature. So for debug logs, we must enable the debug OSPFv3 all CLI, and once this is enabled, just to show an example, I've gone ahead and disabled the router OSPFv3 110 process. So once I disable this, I do a show debug buffer, and under the help context I can see different options, and I'm selecting the module option here with the respective module that I need information for. So here it is the OSPFv3 AF. So once I run that, you can see a snipped output here of the OSPFv3 AF debug logs. So that is how you take the debug logs for this particular module. Following this is the event logs. So in my 8360 switch, I did a show events -c OSPFv3 just to get events for this particular module. Or if you want the most recent events, just do a show events -r and you'll get the list of event IDs for OSPFv3. OSPFv3 AF event logs are also embedded in the OSPFv3 itself. We do not have a separate module for AF in event logs. So let's quickly look at a recorded demo. Address of 1.1.1.1/30, and I'm also assigning an IPv6 address of 1:1/64 just to be consistent with the IP addresses and for easier understanding. So now I'm getting into the OSPFv3 context. So under the OSPFv3 AF context, I get into the help mode and I see 1 to 65,535 range of process ID, which I can assign from. And I also have other options like authentication, encryption, IPv4 and IPv6. So following this, I will also decide the process ID and if I'm assigning an IPv4 unicast or an IPv6 unicast. So here I'll first go ahead with IPv4 unicast and the respective area for it and its instance ID. So I get into the help context and I assign the instance ID. I try to keep it as a default as that is the best practice. And for IPv4, I'll assign the instance ID to be 64 and you can see that OSPFv3 AF process is configured. So similarly, I'm also doing it for OSPFv3 AF with the process ID of 110 with IPv6 unicast and area 0 and instance ID 0. And you can see that OSPFv3 AF process is created for that as well. So I do a show run, and you can see the global context for router OSPFv3 AF 110 and the interface level configurations for OSPFv3 AF 110 process as well. I'm also creating an interface loopback 1 with the respective IPv4 and IPv6 addresses as shown. So it will be 10.10.10.10/32, and I'm also trying to be consistent with the IPv6 address, and I'll assign it as 10:1/64. So here again, I'm populating the OSPFv3 AF commands so that will also take part in the routing processes and gets advertised to my peer. So now let's do a show IP route, and you'll see the routes that are configured. That is both on my interface and the loopback one. So I'm also configuring a static IP address here, 100.100.100.0/24 null route. And let's do a show IP route, and you can see that static route has also come up here. So on my other switch as well, I'll pass the same configurations. So here I have 1.1.1.2/30, I have 1.1.1.1/30 on my left, and similarly loopback 1 on left and loopback 2 on right. And finally my global router OSPFv3 address family contexts for both the switches. So now you can see that the routes are being learned or advertised over OSPFv3 AF. So I'll do the same on my second switch as well, and you can see that the 10.10.10.10/32 loopback is learned through OSPF. So next is under the router OSPFv3 address family 110, I have address family IPv4 unicast. So I was talking about the static route earlier, so I'll try to redistribute the static route. So redistributing the static route can be done only under the address family context. So I'm trying to redistribute this route, and let's see how it comes up. So here's my respective show IPv6 route output as well. And now let's get to the other switch, that's my peer, and see that my static route has also come up here. So let's do show IPv6 route for this, and you can see both IPv4 and IPv6 routes are in place for both the switches, and neighborship is being established over OSPFv3 AF. So here are few show commands that I'd like to talk about. We already did see this in the troubleshooting part. So under the show OSPFv3-AF context, you can see a list of commands here, and you have IPv4, IPv6, neighbor information, routes or statistics. So all this information can be obtained from here. So I'm doing a show OSPFv3 AF interface, and that particular interface name 1/1/15, and you can see all the details here, ranging from the status, the hello interval details, the link speed, the cost calculator. So all these details can be seen here with the show OSPFv3-AF interface 1/1/15. And if you get into the statistics, you will also see the number of packets transmitted and received and the ones that are dropped. So similar output on my second switch as well. You can see that the OSPFv3 AF status is up. So I'm doing the neighbors, and I can see both my IPv4 unicast and IPv6 unicast neighbors here. as well as from the second switch once I issue this show IP OSPFv3 AF neighbor command. So next part is debugging. So I'm just trying to disable the router OSPFv3 AF 110 process ID and see if debugging logs are coming up for this. So I'm enabling the debug OSPFv3 AF all and getting into that particular module of OSPFv3 AF. So now let's see the debug logs that come up for that particular module here. So that is how you enable the debug logs and obtain the logs for OSPFv3 AF. So moving on, we'll also talk about event logs. So let me just do a show events-r and you can see the most recent events, and you can filter them with respect to OSPFv3 alone by doing show events-c and then OSPFv3. So a few commands can be executed only under router OSPFv3 AF address family contexts. For example, so here is the list. So under router OSPFv3 AF 110, I can see a list of commands. For example, address families, enabling or disabling the process, and then ending or exiting the current mode, graceful restarts, max metrics, router ID, and then reference bandwidth. All these can be assigned under this context. So I'm getting into the address family, and let me get into the help context. You will see both IPv4 and IPv6. Similarly, in IPv4, you'll see only unicast, which is enabled right now for 10.15. And under the unicast family context, you will see a few more commands here, like active backbone, area, redistributing, distribute list, max metric, maximum paths, passive interfaces. So all these are enabled under the particular unicast address family context. So that's it with respect to the address family context. So it will be the same case for IPv6 as well. I just showed you an example with the address family IPv4. So that is it with respect to the demo. Thank you for listening, and please join the HP Aruba Networking AREDS community today, if not yet done, by scanning this QR code